All right, number 9. Andrew pulls a 0.75 kilogram toy car with a horizontal applied force of 4.3 newtons. The car is moving with a constant velocity. So constant velocity means all the forces have to balance out. All right, there's no acceleration. Draw a free body diagram. Okay. So here's my free body diagram. Number 9. Terrible marker. Number 9. Car is going to have some force due to gravity. The car is going to have normal force. Holds it up. The car is going to have a applied force. You can put FA or FA. And opposing it, it's going to be some sort of frictional force. Is that what they wanted? Force applied, force of friction, force of gravity, and the normal force. Good. Okay, calculate the force of friction. Well, you know the applied force is 4.3 newtons. You know the net force has to be 0. So the force of friction has to be 4.3 newtons. That's easy. All right. And 4.3 newtons backwards to the left. Calculate the coefficient of friction between the car tires and the floor. Is this the coefficient of static or kinetic friction? So your friction equation is force of friction, coefficient of friction times the normal force. So 4.3 equals the coefficient of friction. We got to figure out what the normal force is. We know that the car has a mass of 0.75 kilograms. If we want to get that as a force, we got to do 0.75 times 9.8. 0.75 times 9.8, 7.35. So the normal force, since this thing's not falling through the floor or coming up off the floor, 7.35 newtons of normal force. We got to balance each other out. So that tells us what we got to put in here. 7.35 newtons. 4.3 divided by 7.35 gives me a coefficient of friction of 0.6. Coefficient of friction is unitless. So it ends up being 0.6. And is that what they got over here? Yeah, 0.58. Okay, if Andrew pulls the car for 2.3 meters, how much work does he do on the car? Work is force times distance. So work is the force he applies, 4.3, times the distance he applies it for, which they tell you in the problem, is 2.3 meters. 4.3 times 2.3. 4.3 times 2.3 gives me 9.89. Big J, joules. Cool. That is number 9.